Hey guys, it's Ben from Myers Woodshop.
And I'm Peter with Rowdy Roman.
And I do a lot of laser stuff on this channel. Like this laser, or the one Pete's coddling.
This little baby laser.
Well, and the big laser. Well, came out to the shop, found out lasers had a baby. Check this out. She's so pretty and tiny. The big Aeon had a baby and made itself a K40. If you haven't heard of my friend Hamilton Dilbeck, I'm gonna post a link to his channel right here. He also had a baby and got the baby K40. His video is hilarious, and he talks about the relationship he has with the father of this baby who gifted him that.
I believe the great minds think alike, so we are eager to make commercial cooperation with you. Your gorgeous and effective efforts deserve great reward. I mean, you're not wrong about that, Conan.
I kind of have the same relationship, although I'm not gorgeous and handsome. But, oh well. This is the K40 CO2 laser. You're used to me either showing off the big OM Tech 60 watt laser I had, or the Eon laser that is a 90 watt, or a bunch of diode lasers. Well, this is kind of an in-between step. We have a powerful K40, but yet just in a way smaller package. So with the 60 watt and the 90 watt Eon that I have, you can see that the bed size is way bigger. This one is a 900 by 600. It gives me a lot of room to work. So this laser is way, way smaller. So it came to us like this. Basically, the bed inside is a size of a sheet of normal printer paper. So this is the stuff that came with the printer. We have the 4-inch exhaust hose. We have instructions. We have a little water pump that we need to pump water through this laser to keep it cool. We have a bag of all the accoutrements that it'll go with. And this is the inside of the laser. These are the water lines we're gonna hook up to run the coolant. You need coolant for a CO2 laser. And this blue down here, that's the actual bed. The stuff with the grate, that's the bed size. And this is the laser head. And then we have this black piece back here, that's the fan scooping all of the air out. So that's what the inside of this looks like. We don't have a bed that goes up and down like we do in my bigger lasers. So you're not gonna be doing any tumblers or cups or anything. You're basically doing flat pieces of wood, glass, acrylic, stuff like that. So one thing that's different is the controller and how it operates between what it looks like over here and what it looks like over here. Let me show you the big laser first, and then we'll come over to the K40 and see what that looks like. So here's the big laser, and I'm gonna turn it on. I have a screen that shows me what all is going on. Right now it's gonna home. It's gonna find its limits, how far it can move. Every laser will do this, so this is no different on this laser than it is on the little K40. Just gonna take a minute, and then I have some arrows and buttons where I can actually control this laser with this screen and the panel without it connected to a computer. So if I push the arrow up or down, I can move it left and right. I can set origin, I can move the bed up and down, and that's all done by this smart controller. Let's take a look at the K40. So here's the K40's controller area. This is a essentially dumb controller compared to the bigger one. I did find this little washer sitting right here on the controller. Again, this is from like super cheap Chinese $500 machine, so I have no idea what this washer went to or the quality control that they did. We have the simple on and off button here. We have laser powering, 10, 1, or 0.1. We can test fire the laser and the laser switch on and off, and that's it. We can't move the machine in any way unless it's connected to a controller. Big emergency stop if we're in the oh crap moment. And then we have the temperature for the LCD and the temperature for the water, and then the temperature for the power supply. So that's all that this does. So now we're gonna figure out how to make this thing work. We have an instruction booklet that I am sure is Chinglish and probably absolutely terrible. we've been around enough lasers to kind of know what's going on, so we're gonna wing it and see if we can figure it out. First things first, we're gonna pull the water hoses that were up in here. We just pulled them out the back, because one's an inlet and one is an outlet. And we're gonna have to jerry-rig some sort of device that'll hold our water. We're gonna use distilled water. It's very important to use distilled and not normal tap water, or you're gonna grow fungus, which will ruin the laser and such. So it's like $1 per gallon, maybe $2 now that inflation is so high. Pete went and bought just a Tupperware from Family Dollar, and we're gonna make that into basically our chiller. Now there are expensive chillers out there for a K40. Don't waste your money, not important. We're just gonna use a Tupperware of water and fill that up. I use it for the spindle back here. I've done the same thing. I just have a Tupperware of, I use RV anti-coolant in there, but we're just gonna fill that up with distilled water. The bigger the bin, the better, because you're gonna distill the hot water over more area. But I find that this is probably a fine size for this kind of laser. So Pete's gonna go ahead and fill this up. Then I suggest cutting 2 holes in the lid and then having these go down into. All right, what we're doing is grabbing a drill bit that is needs to be slightly bigger than the plastic. Maybe the same size, because the plastic can flex.
Yep.
Same size of the tubing. Tubing is going to be a weird Chinese millimeter. I say weird, but 90% of the world is using it. So we're going to get close with our Imperial. So when I do this, I would suggest putting the holes opposite of each other. That way the hot water comes out and we're sucking from the cold side. We're gonna put 2 holes opposite each other, one over here and one over here. That way the hot water comes in over here and the cold water comes out over here, so they're not right next to each other. And as Pete has shown us, if you do it that way, you're gonna break it a little bit. Which is fine. We're just gonna get some grommets, but put a piece of wood behind it and it'll hold it from tearing out, maybe. Oh well. One of the issues you're gonna run into is the power cord for the pump. You gotta run this somehow through this and you don't want a big hole. So what I've done is I cut this power cord, I cut the power cord somewhere down low and stick it through and then splice it together. That way we don't cut a really big hole. Only do this if you're comfortable with wiring, but this is pretty easy. There's just a positive and negative in this. All right, here's what we have on the back of the unit now that we have our pump all set up. So we had a water inlet right here. This is where the water comes in. It's labeled. This is the water outlet. That's also labeled. These are already connected inside, so we didn't have to do anything with those. We just had to poke them out through here. We have that coming in to the top of our Tupperware, I guess, holder, and we have the pump fully submerged in here. We have the power cord for our pump, and we have a water pump labeled. We have 2 power cords here, so we're just gonna plug it in to that, and that will take care of our pump. We have our extraction fan right here. It's very important to extract all these fumes out. So we have here basically a dryer hose fitting, and we're going to attach that onto the back of this with the 4-inch hose clamp that they provided. We're just gonna slide it over here, pop this on here, and get a drill and tighten this up. Now, for the purposes of this video, we're not gonna have this attached to anything because we're in an open garage, but generally you want this pumping outside. I cut a hole in the wall to my shop last time and this time and put a dryer vent duct out the hole. So we'll just tighten this down. All right, so our hose is on. Now we just attach this out to the house. But again, we're just gonna pump it right here. So that's the back. Final thing we have in the back is a ground wire, because a lot of the Chinese stuff isn't grounded and wired properly. You can throw a grounding wire from here to a ground area. I'm not gonna show you how to do that. And then finally, we can plug in our 110 input. This is a 110 laser. We don't need 220, and we are set. So let's go back to the front.
And this is going to be really satisfying for you all.
This thing really does suck to peel off. Hamilton was not wrong. It doesn't come off very easy. And to get to the other side, we're essentially gonna have to take off all these bolts and peel the other side, because it's got protection on both sides. That way it's not scratched when it ships. This is kind of expensive acrylic because it stops the laser beam from hitting your eyes. So you don't want to screw this up. But we're gonna take these 4 bolts off to remove the protective paper, because we can't get to the upper side. All right, now we can peel the other side off.
All right, guys, you got to make sure not to tighten the bolt down it too tight, or else you will crack the acrylic.
Granted, you have a machine that can cut the acrylic, but that sucks to be your first project. That can't cut as big as the piece. All right, this stuff down here, this is a protective film. This will also be satisfying. And it's gonna be harder to get, that is not attached to this plate, but it won't be as easy to get this blue film off. I'm gonna shoot this laser head forward. Give access back here. You probably wanna remove this fan head. Actually, you know what? Let's go back in the back and show actually the laser tube. There is some blue right here as well. We can take off of the laser head. I don't know why they don't remove this before they ship it, because now I gotta take that whole head off to get all the blue out. So back here they have a screw in that hole. You need to remove that. It's a Phillips head to check out the laser tube. So this is the laser tube. I'm gonna check this out. You can see we have, this is the outlet water. This is where it comes in. It flows in through here and goes this way. You can check out the model. This actually says a 41 watt. That's what your laser tube looks like. The end here, that's our first mirror. And so the beam comes out through here, hits this mirror and goes through this hole. Goes to our second mirror inside over here. Woo! And then it goes this way to the laser head. That's a third mirror. And then a fourth one going down. So it doesn't look like we have access to that smoke extractor thing. I think we have to remove these, and this piece pops out, and that's probably attaching the smoke extractor. We're gonna try that out to get that blue stuff off. And if you take a look inside, there are 4 bolts right here, and that's holding that shroud that is covering that. So we're gonna remove these 4 bolts. We can remove the shroud and take the plastic off. Okay, Pete just loosened the 4 bolts in the back. And now we can lift the fan shroud kind of up and out of the way to peel back the remainder of this blue. And now we're nice and golden under there. So the unfortunate thing is now he has to put them all back the way they were. So we got everything off. We're finally ready to start using it, but there's 2 things I want to do before we do that, just in the interest of what is in this thing. So the first one is, it's got this little panel that looks like it could pop out. I'm curious if we remove these 4 screws, if we could put something larger in there, like maybe a tumbler or something round, some object like that. So Pete's gonna pop these screws out and we're gonna see what we have underneath this panel. All right, the screws are out. Let's lift up the not that one.
Good golly.
There it went. All right, the screws are out. I'm gonna take the panel off. And you can see we really just have a nothing space down here. Oh, this is interesting. This is spring loaded. So maybe we can do something, which this is totally not what you would actually do, but if you wanted to laser something, you could actually hold it like this and laser an edge, piece of wood or something. Granted, it's very tiny, but that's an interesting use of space. We could possibly fit a tumbler under there. You're not gonna run a rotary, I don't think, but oh, you can fit a tumbler. This is a Yeti, so you could fit something to where you could do some lasering on it. You just wouldn't have, you'd have to kind of correct the curve. Maybe there's a rotary available for this, I'm not sure. Again, we're going into this blind, but here we go. So yeah, that's what this panel is. We'll put it back on for now, and then we're gonna move over to this panel and remove it and see what the guts are of the thing that makes it work. Okay, if I were to read the manual before doing any of this, I see a picture of something wedged in here. So, where's that square? Oh, it's over here. So another way to use this, since there's got a groove in here, we can actually put it in this way and push it that way to where it's clamped now. Instead of, if we have some bowed wood or something, it would actually be clamped down. So that's another use of this feature. Not only are we vertical, we're also horizontal. So that's another thing. I guess read the manual before you get this. All right, we're gonna take a look under the hood. We are unplugged for this part. Again, we have a screw in here just like we did for the laser, but this is what it looks like on the inside. This was the first question by everybody. Why are these two on with no power? Because they show the temperature. And the reason is because they have a battery in the back of these. You can see this one's going with a temperature reader right to the power supply for the whole thing. This is the power supply for the laser and the controller. Since the controller is just this LCD and there's a board over here, it's got one power supply. Most lasers that I've used, the bigger ones, they have one for the controller and one for the laser tube. Again, we have one right here that's going to the laser tube. That's going to tell you how much, I guess, the water is cooled. Here's our E-stop button. If we hit this big red button right here, it cuts all power to everything in case we're in the oh crap moment. We have the power on and off, and that's right here. And that's going to the power supply. Now, let me pull you over here. Here is the brains of the operation. This is the motherboard for our laser. So we have everything connected to it, and we have a USB port on the side that sticks over here, and this is how we connect our laser to the computer to actually make it run. So that is all the inside guts of the machine. Okay, so we're ready to turn it on. We've done everything we could. It's plugged in. And the reason we're looking at the tube first before I hit this switch is because we want to make sure it fills with water. When I hit the switch on, the pump should kick in and the water should fill. So let's check it out. Are you plugged in with the power switch?
Yeah.
Ha! E-stop button is on. Twist the big red E-stop. There we go. So we can see the water is flowing right here. It's cranking down through, and we're pumping over in the pump. So you're gonna make sure it goes and fills up where there's no more water bubbles. So you're gonna let this cycle for quite a while, and maybe 2-3 minutes before we're ready to actually fire anything. So you can see when we're on, we have an LED light to illuminate everything. It's only one strip, but it's better than nothing. So we can't jog it around. Now is the time when we plug it in and get started. Usually my videos are really informative and walk you through the step-by-step process. Since this is just, will the K40 work and is it worth it kind of, it's just a baby of these, I'm not gonna show you the software of this because I don't know if it sucks. I don't know if it's gonna take me hours to figure out. I know that I gotta use some drivers. I use Lightburn. Lightburn is the best laser software, period. It's in the description below. I get no affiliate from it. It's just the best, period. I'm gonna try to make this work with Lightburn. Hopefully it does. I don't know if it actually will because it requires a certain driver and controller. But if not, we're gonna use the weird Chinese software that comes with it, and we're just gonna get to it. So that's preference of, I will not teach you about the software for this, at least not in this video. So we're gonna cut right here. I'm gonna go learn the software on my own, come back, and we're gonna show you if it will cut.
All right, long story short, we got Lightburn working with a K40. We'll put a link on how we did it in the description below. Right now, we are framing what we're going to laser onto the wood.
So it just did a square where it's gonna laser. So we're gonna hit fire with the door open and see if it actually does it. There is a switch right here that allows you really to fire it. It won't fire if the door's open because this switch says we're open. But if you wanna trick this, do not do this at home because it'll burn your eyes. But I run this a lot for filming with it open. Just push this thing down and hold it down. A piece of tape will work just fine and it'll fire. I'm gonna tape this so you can watch as it goes. Before we do this, we're gonna hit fire on it right now with the door open and show you that it won't fire while the door's open. So it's actually moving, but you can see it's not doing anything because it won't fire the laser with this down. So we're gonna stop it. All right, I'm gonna tape this switch down. So now that engages the switch so it thinks that this door is closed. So now we can watch, hopefully, as it burns.
Ready?
Yep. And you can see it's burning now. We got the dust coming off. What are the speeds and feeds for this?
Let's see, 100 millimeters per second with a speed of 10 millimeters.
So that's what we're just guessing here. But you could see the smoke coming off the back. So the fan is doing an adequate amount of pulling the air out. Now, just for comparison, when I run this on my Mira 9, the 90 watt, to engrave a light engraving like this, I'd probably do 2,000 millimeters a second at about 10 to 20% power. And this is going 100 millimeters a second. So I'm running, what is that, 200 times faster? 200 to 20 times faster. 20 times faster.
This is 20% power.
20%, okay. Yeah, I'm running 20% faster. What's the time it gives you that it's gonna take this? If you hit the preview button in Lightburn, up at the top.
Yep. 4 minutes and 38 seconds.
4 minutes and 38 seconds. So I can run this 20% faster on my Mira. That's probably like less than 60 seconds to do this same thing. So if you're in a production shop, this is not the machine to do it. You want a big industrial one, but you're gonna pay for it. But theoretically, that would pay it back. Enough of us talking, we'll just let this time lapse. Again, we're gonna speed this up because it's gonna take forever. But we are getting a good burn within our first try. So that's great news. And we're done. It just finished. I'm gonna move it. Again, I can't control it from up here, so I have to move it from the Lightburn screen. So I'll click home, and I'll move out of our way, and we have a nice burn. It's actually pretty deep in there. And that was what, 20% power? 20% power. We could probably speed it up and pump up the power and get a quicker engrave. So let's go ahead and do that. We're gonna crank it up. It says 500 millimeters is as fast as it can go. So let's go ahead and turn it to 100% power and 500 millimeter speed and see if we can get any faster with good results. So we just went from working to let's see how fast we could possibly get this going. So we're framing it. Yeah, that looks great. So go ahead and fire. Oh, let's see. Let's preview.
Too late.
That's okay. Let's hit preview and see how long. Okay, we're gonna stop because that is obviously too fast for this machine. It cannot handle 500. Even though the manual said something about 500, that is too fast.
Yeah.
So we're gonna come back and we're gonna lower it down. We're gonna try to find the speed it actually can move at. So let's check it out. All right, this is 250 at 80% power. Let's see if it'll hit that. We will do 250 at 80% power. It is way too high.
Way too hot.
Way too hot for 80% power. Okay, we're stopping it because we know we can hit 250. 80% power was a little too hot. So we're gonna go ahead and go, let's try 300, and then let's try
300 millimeters per second.
Yeah, and then we'll move up to 350 and then move up to 450. Let's see if we hit any of those. So we're just gonna cut really quick and show you if any of those work. What is it?
300.
So 300, we can say safely works.
Yeah.
Yep. And it's coming out pretty good. This is 80% power.
Oh, I think it might have just skipped it.
So 300 is, yeah, 300 is too fast. We can hear the motor skip. It can't keep up with the machine. So 300, just barely working, but not quite. And the other one was 250.
250, I would say it's max.
We could probably push 275, but getting up to that, I would be afraid of skipping more steps. So we're gonna say 250 is probably max on this machine. The nice thing about this machine, it's firing perfectly fine without aligning any of the lasers. That's a whole other video, a whole other subject, but I haven't had to do that. This was just out of the box experience, and we're really good on that. So we're gonna count 250, engraving, good. Let's see if we can cut some acrylic. All right, so what we're gonna do, we have some optics, acrylic sheet, 0.08 inch. This was from Lowe's, I think. And we're gonna plop it in. If we use the focus tool, we are a little too short, but we're gonna see if we can cut through this regardless of the focus. So we're just gonna stick it in and we're gonna give it a cut. All right, this is
13 speed.
13 speed.
20% power.
20% power line, trying to cut through 0.08 acrylic. Here we go. This stuff stinks. And let's see if we cut through. No.
I don't even think it's close.
I don't think it's close.
Maybe
Nope.
because we're out of focus a little bit.
It is not close at all. Let's go ahead. We are out of focus a bit, so we're gonna lift it up on this piece of wood. We're gonna try again with it more in focused because it was out of focus, and that focus could be a big part of why you don't cut through. So that looks good. Go ahead and try cutting. All right. Nope, not through. I'm gonna remove this. Let's try.
A different power.
We are deeper that way. It definitely is deeper. Yeah, I can feel it with my thumb. We went deeper. So, yeah, what was that power?
20.
20. Let's crank it up to 50 and do the same speed.
Still doesn't look like it's been doing it.
Did you try it?
No.
We are.
Closer.
Oh yeah, we're much closer. Much closer.
What about where the sticker was?
It feels the same.
So let's just do.
We're close. You gotta slow her down a little bit, I
Yep.
think.
Go down to 5.
What were we at?
13.
13?
7.
7. Let's try 7.
Oh yeah, that did it.
That did it?
Yeah, it went right through.
Oh yeah, that was too slow. So we're good. We cut out. I can't see anything. It still can't see. Okay. Ah, it's hot. Wow. All right, that cut it out. So we can definitely cut out acrylic with this. We have a lot more to do. Again, we're not aligning any mirrors. We don't even know if they installed this mirror the correct way, but we are still cutting, again, with basically just messing with speed and power, and that was the goal. Does this cut with just speed and power? So, yes, we got acrylic, success.
All right, guys, we tried 16th inch acrylic. We tried a bunch of different speeds and feeds. We ended up right around 7 millimeters per second at 50% power, and it dropped out as soon as we picked up the acrylic. Something else that we did was we checked the mirrors, and we just used some IPA with like a microfiber rag and cleaned all of the mirrors. They were pretty filthy. So, but we're all good. Once we clean the mirrors, you could actually see the beam a little bit better, but that's acrylic right there.
The only difference is we have not aligned the mirror still. That could be a huge difference in power, and we're gonna do that later off camera. This is just, can we use it out of the box? And so far, we're good. We're gonna give it a try in wood, and that'll be our final test. This is 1/8 inch plywood. All right, this is our material test for the wood. This is 1%.
No, 1 millimeter per
1
second.
millimeter per second. I think it is too slow because it's actually flickering. But we're giving it a try. It cut it. It fell out.
That's 20% at 1.
Well, it worked.
This is 20% at 5.
I don't think that cut it out. That looks really good.
This is 10, this is 15.
No, these are definitely not gonna work.
So here's 15 at 30, 10 at 30, 5 at 30. Staring at it.
Is that one?
Yeah. It's like you see the...
Burning your brain. Well, we can confirm that we definitely can cut 1/8 inch plywood. So that's pretty good.
Super slow.
Yeah, that's all right.
We'll see.
We might get faster as we get higher power. This is real time right now. All right, so our test is done. We're gonna move it out of the way. We're gonna lift it up and see if anything falls out.
Ooh.
So that's what falls out. So our best one would be this bottom one. And what is the speed and feed of the bottom one,
5
Pete?
millimeters per second at 50% power.
5 at 50. I think this one will poke out. Yep. And that one was?
5 at 40.
Let's see if this one pokes out.
Nope.
No. This one? No. If we look at the back, none of the other ones came out. So we're between this and this for plywood, and remind us again what these were.
5 millimeters per second at 50, 5 millimeters per second at 40.
So we're at 5, and what was these two over here?
10 millimeters per second at 50, and then this is 15 millimeters.
So we can dial in between 5 and 10 probably and get an even better cut with a little bit faster. But we are cutting through 1/8 inch plywood, so that's a successful test. Plywood, we're good. Acrylic, you're good. That's probably 90% of what you're actually gonna cut in here, so looking good so far. All right, guys, so that is the majority of this test. It was just, can we unbox it? Will it work out of the box?
Yeah.
And what do we think? So again, we figured out how to use Lightburn with it. Again, we're gonna have a link to my blog on the description how to do it. It's a little finagled, but it wasn't too bad, and it works pretty well.
Took 5 minutes.
Yeah, 5-minute change. Lightburn is definitely the way to go, but it works. I'm impressed with this little machine.
Yeah.
I am impressed. It cuts acrylic and it cuts wood. So that's 90% of what we do anyways.
Yep.
The size is pretty compact for the power of what it is. Again, like I have some lasers. They're still in the box, but these are diode lasers, and that's the box it comes in. So we're about maybe when it's set up the same size. So we basically have diode lasers that are not CO2. We have this little CO2 laser, 40 watt. And then we have the big stuff, the 60
Or
up
90.
to my 90, 150 CO2 lasers. Those are kind of the 3 levels of things. And I think this has a place.
Yeah.
And obviously, I'm cranking out production stuff with my big laser. That only happened over time. Diode lasers have a place because you can strap them to, like, I mean, my Onefinity has one. You can strap it on. You get a big bed with that.
Yeah.
They're relatively inexpensive, but you're basically engraving, and that's it.
Yeah, not cutting.
No, this thing cuts, and that's the major difference between a diode, which is maybe $100 less. This was $500. I've seen some diodes at $500. They say 10 watt. This is a 40 watt, so it's a major power upgrade for about the same price. The only difference is a diode laser can be sat on top of your material. So let's say you're gonna laser a door and you wanna put your name across the top. You can sit your diode laser, because it's so light, just sit it right on top and laser. This has to be this small to cut, or you can't fit it in here.
Yeah.
So if you're gonna do something large and you just wanna engrave, diode laser is probably the way to go. If you know your material is generally gonna fit within here and you want to cut, this is the way to go for sure.
Yeah.
For the same price. Maybe you buy both, you're at $1,000 and you're still $9,000 less than what this one is. So you know what I mean?
Yeah. I mean, it could be like an introduction to like production stuff if you're doing small stuff. Like my plan is to cut acrylic with it. That's it. And I have a small shop and this fits right in there. And that's my plan.
So the great thing about it is, I know $500 can be a lot of money depending on your budget, but $500 is so cheap for an entry level getting into the machine. This takes up almost no room. You could have it in a bedroom if you wanted, if you're cranking out the window, and they hold their value. I guarantee you I can turn around and sell this for $500 straight up on Facebook Marketplace today. And I'm out basically $0. Just maybe the cost of software if you buy Lightburn, which is like 40 or 50 bucks. And then you can use that software with any laser on the planet, basically, so you're not missing out on anything. This one's a little harder to get somebody for a resale value, although it is worth it if you're gonna locally sell it, because, I mean, I can't ship this thing. It's huge. So the resale is a little different situation with a big laser. Diode, usually, you lose maybe $100 and somebody will buy it secondhand. But I'm super impressed, and you'll be using it production-wise. So follow Rowdy Roman on Instagram, Facebook, and you'll see him using this in his production. He runs a 3D printing business and has some CNC stuff coming out that's going to need acrylic. And that's kind of the prototype of what we cut out here. And we have a successful cut. And you can kind of set it, forget it, let it cut in the corner of your shop while you're doing other things.
That's right.
And we'll be golden. I mean, I really think that the chiller is working out well. We got up to maybe 32 degrees Celsius. Generally, with a actual chiller like refrigerant, 19 to 20 degrees Celsius is where you want to be. So perhaps we'll probably put maybe an ice pack in here from like the fridge, like you put in like a kid's lunchbox, kind of bring it down. Maybe invest in a chiller if you're actually cranking this out. That chiller could be used on a bigger laser if you upgrade. So you don't lose value by investing in a chiller. But so far, that little thing's doing great. No problems. I'm so happy that we plugged it in basically and it worked. Again, this is Chinese, so it's kind of a hit or miss thing, but so far so good. CE and FDA approved. A lot of Chinese stuff doesn't have any of that, so that is a definite bonus to this one.
Well, I think one of the other things just to be aware of, since you can get it with Lightburn, that opens your door up to having the Lightburn camera. So you're not having to guess where you're going to cut out your material. The light burn camera will just, boom, see exactly right, and you can place your design right where you want it.
I'm gonna link that Lightburn camera design video I did to show you what's up. It basically turns all your scrap into usable space because you know exactly where it's gonna cut when you overlay that in Lightburn. I have one in my big laser and it's up here, and it is an absolute add-on for me. Because this doesn't have a red dot, when you're moving the laser to align things, this is where a camera absolutely comes into play. You don't need that red dot. This one has a red dot, and now I'm like 50-50 on using the camera and just the red dot to see. This one has no red dot, I need the camera. If you do get the Lightburn camera, which we're definitely gonna install in here, I have a camera mount that will double-side sticky tape right to it on my Etsy page. Link in the description, check that out. It's a must. And not just because I sell it, I don't care if you get the camera mount somewhere else. It is just, it makes lasering so much better and so much easier. It's definite, and we're gonna install that and follow Rowdy Roman Pete to see how he does that. Only other thing that we may install later on, well, two things we're looking at. One is a milliamp reader, so we know we're about what we've seen online. 16 milliamps is where this kind of maxes out in power. So the only way to know that is if you have a milliamp reader. I also have another video right here. You can check out where I installed one on my OM Tech. And the other thing is you're looking at a different board.
Yeah, different motherboard that works directly with Lightburn, so I don't have to do the workaround.
We're doing a little bit of the workaround. Again, that link's in the description. It's a 5-minute thing, but first world problems. You have $100 to spend, $200. You can bypass, you don't need that workaround anymore. Save a little bit of time. That's probably where we're gonna invest. Make this thing that much better.
Yeah.
Pete, final thoughts on this K40. Is it worth it?
Yeah, I would definitely say if you're running like an Etsy shop or something and you need to crank some stuff out and it's gonna be more production, then yeah, absolutely. And you just need the small work area, this is a great entry level machine.
I think it is fantastic. I'm really impressed with it. I'm glad we got one in the shop to take a look because I've been seeing them forever. And I think if you're looking into getting into the lasering world, skip the diode lasers and buy the K40.
Yeah.
This one, I can't speak for other ones because it's the only one I had. I'll have a link for this one in the description below, but this one is totally worth it. And will get you cutting. The main thing is engraving versus cutting, and this one will actually cut. Diodes just, you're not gonna be satisfied with the cutting speed of the diodes. So
yeah, I mean, a lot of people that are starting in the entry level production, they may already have a CNC, so they're doing all of their cuts on a CNC and then moving it over to a diode laser, where all of a sudden you just get to, you know, cut and engrave on the same pass.
Makes way easier when the software shifts on the fly and does it within itself, and you don't have to move to different machines. Way easier. You're just a happier, better overall experience. I think it's a must buy. My stamp of approval is on this one. It's great. If you have used the K40, give me your thoughts down below in the comments. Hit subscribe, like this video. Hope it helps. Happy lasering. And we'll see you later.
See ya. I think it's nuts that it came all the way from China and the tube is not cracked.
I know. It didn't have any foam around it either.
This is the only foam that I see.
Yeah.
Right here.
And all the test. Boys, you have to be quiet. We're on the camera, okay? If you haven't heard...
I'm Peter with RowdyRoman.com.
Why do I say .com?
I don't know.
It's like, MyersWoodshop.com too.
All right, well,
No.
do it
Good. No, just do what you want to do.
care.